Okay, we are going to have a triangles test. So let me get this started. So triangles test review. Okay, how do you set this one up? Do you say this one equals 180? No, 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 not at all. Okay, this is sides that are congruent. They don't add up to 180, so you just pick two of them, set them equal, right? And then you solve, right? You get rid of the smallest x since you have x on both sides, and that's gone, and you got x is equal to 9. If they want JA, you plug that in. Should be 9 plus 9 is 18, and all the sides should be 18 because it's equilateral, right? Okay, this is the kind where you say the three angles add up to 180. So you say this plus this equals to 180, right? And then you combine like terms. 1x and 1x is 2x plus 2x is 4x, right? Minus 20 plus 6 is minus 14. Then you got to get rid of the 14 and minus 14. You got to add 14, right? Cancel. 4x is equal to 194. Divide by 4, and you get 48 and a half. Okay? Next. All right, remember this one right here, the exterior angle adds up to these two guys. These two guys add up to the exterior angle, right? The two remote ones, the far away ones. So if we go backwards, we could say 150 minus 80, and that'll give us 70. And as you can tell, these two add up to the outside angle, the exterior angle. So using the same concept, we can set up an equation. And it's okay to have y on both sides, right? This one plus this one equals that one. So we say y plus 80 equals 3y minus 22. Okay, y on both sides. Get rid of the smallest y. Subtract that. Cancel. And now you got to get rid of the minus 22, right? Add 22. Cancel. That's 2y is equal to 102. Divide by 2. And you get 51. Okay? Okay. This one is isosceles, right? So this is just extra information down here. Okay, so these are the two, since they're congruent, you set them equal to each other, right? So 3x minus 10 equals 2x minus 2. Get rid of the smallest x, minus 2x. It's gone. X minus 10 equals negative 2. Get rid of the minus 10, add 10, and you get x is equal to 8. Plug back in if you need to. Okay, a problem like this, could you do this problem? Okay, if it says APM, draw the picture. Okay, now it says AP is congruent to PM. Okay, so that means it's isosceles, and those are the ones you mark. Okay, find the measure of angle M. If A is 70, so A is 70, so what's M? Of course it's 70. Okay, base angles are congruent. Problem solved, right? Okay, let's do a different one. Okay, this time, draw the same picture. These two are congruent. It's isosceles. It says find P. That's this one up here. Okay, if A is 70, so we put 70 in there. And if we want to find this one, you've got to use this knowledge that these are congruent. Base angles are congruent in an isosceles triangle, right? So you put a 70 there. Those two add up to 140. So 180 minus 140 will give you 40, and that's the answer. Okay. All right. What type of triangle is this? Well, you got to find x and plug it in to see if it's acute, right, or obtuse, equilateral. Okay. So you take 10x plus 2x plus 6x, set them equal to each other. Set it equal to 180. That's 18x is equal to 180. Divide by 18, and you get x is 10. Plug it in, and plug 10 in here. It'll be 100. So which one is it? Yeah, it's obtuse, right? One angle's bigger than 90, right? Okay, is it a right triangle? Do you remember that if you're trying to find out if it's a right triangle, you got to use the Pythagorean theorem, right? And then you plug the numbers in and see if it's equal on both sides, right? Okay, this is the long one, so that has to go in for the C, and then the 12 and the 5 go in here. Okay, so 5 squared is 25, 12 squared is 144, and this is 169. Okay, so you add these two together, and guess what? 169 equals 169, so yes, this is a right triangle. Okay, here's one that's not going to be. Okay, so we go 6 squared plus 8 squared equals 12 squared. Okay, 6 squared is 36, this is 64, this is 144. So are they equal? Nah. Okay, is this a right triangle? Nah. Okay, now, is it a Pythagorean triple? Do you remember what that means? That means all three numbers are whole numbers. Okay, all three numbers are whole numbers. So this kind we've been doing a long time, and we just learned this one, okay? This is the adding Pythagorean theorem, right? Because you're trying to find the hypotenuse. We did this a lot because on graphs we would find the distance, right, between 2 points or the diagonal line. Now this one is the subtracting Pythagorean theorem. They actually give you the hypotenuse first, right? And then you do the subtracting Pythagorean theorem, and you have to put the big one first, or else it'll give you a negative number, which is imaginary. Okay, so you put 13 squared minus 5 squared, and that is 12. Okay, if this one's 12, then we have a 5, 12, 13 Pythagorean triple. Okay, because all the numbers were whole numbers, right? Now let's try this one. Okay, would I use the subtracting one on this one, or the adding Pythagorean theorem? Yeah, this is the adding Pythagorean theorem because the two short ones give me the hypotenuse, the big one. Okay, so I go 6 squared plus 8 squared, take the square root of it just like we've been doing all year, and that is 10. Yes, it's a Pythagorean triple as well. Okay, 6, 8, 10 is a Pythagorean triple, 5, 12, 13 is too. Okay, okay, so what reason are these two triangles congruent? Yeah, you know, side, 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 right? Okay, what about these two? We've done this today. Side angle side, right? Okay, this one, angle side angle, right? Okay, this one, this is the weird one. This is the angle angle, and then another side, some other side. Okay, so this is angle angle side. If this was angle side angle, like some people try to say, then it really would be here, but it's not. It's just two angles and then some other side. So angle angle side. It can go backwards or forwards as long as you got two angles and then some other side. Okay. Whenever you have a 90, it's a right triangle, then you always check hypotenuse leg. This is the hypotenuse, right? And this is the leg, one of them anyway. So if you have a hypotenuse and a leg congruent in both triangles, then it's HL. Sometimes it's not. Sometimes you'd use side or angle side angle if you don't have the right markings. Okay, so I have two parts in each triangle marked, and of course I've got the shared reflexive side in the middle that I can say whoosh, and do the Wolverine, right? Okay, so what is this for these two triangles? Yeah, side, side, side. Okay, once again, uh, this is parallel lines, right? So you know it's going to have alternate interior angles that are congruent, right? And then you also have the whoosh in the middle. And remember we said that parallelograms like this with the line down the middle, diagonal, is always angle side angle. Okay, let's show you. Okay, this angle is congruent to this one. This one is congruent to this one. And then whoosh. So this is angle side angle. Okay. Next, is this congruent? No, this is angle side side or side side angle. It's the bad one, right? So not congruent. Okay. Okay, on this one, uh, is it hypotenuse leg? Well, they got the hypotenuse mark, but they don't have either leg mark, so it's no. Okay, but these are vertical angles, aren't they? So we can mark those. And now we've got angle, angle, side. Okay, angle, angle, side. Next, are these congruent? Nah, this is angle, 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 the bad one. Okay, it does not prove it to be congruent. Okay, what about this one? So this is side and some weird looking angle and a side. Okay, so side, angle, side. Okay, all right, this one, okay, it has a 90. Don't think it's angle side side, the bad one. It has a 90, so check to see if it's hypotenuse leg, which it is. Okay, next. Is this hypotenuse leg? We got a 90. Yeah, there's the hypotenuse that's marked in both of them, and then we have a leg, so that's HL as well. Okay, this one, we've got vertical angles, so we can mark those, and we've got side, angle, side, right? Okay, and then here, this is the midpoint. It says R is the midpoint, right? So if it's a midpoint of ST, then we know that these two are congruent, right? Okay, then it says, what would prove these two triangles congruent by side, angle, side? Okay, well, there's a side, there's an angle, that has to be this side, right? So is there a US and a VT? Oh yeah, yeah, right there. Okay. That would prove it by side angle side, side angle side, right? Okay. Wasn't the hypotenuse is not marked, so it's not HL, right? Okay. Now this is the one we did in class as well. Okay. These two are perpendicular, so that means that these are 90s, right? T is congruent to M, so I can mark that. And then we do the whoosh, right? And which one is it? Yeah, it's angle, angle, side, because the hypotenuse was not marked. You couldn't say hypotenuse leg or anything, okay? So angle, angle, side, all right? Next. All right, are these two, well, what would make these congruent? Okay, we did some of these two. Okay, this is a, let me see, G and M, no. Okay, J and M, yeah, that's the one. J is, J is congruent to M, okay, because this one would make it angle, angle, side, and this would make it angle, angle, side as well, okay? All right, so here's a new problem, okay, different answers. Okay, this one is, let me see, JN, let me see, JA, MN, no, GN, yeah, G, if this one's congruent, that's angle, side, angle, and then N is over here, right, which is angle, side, angle, right? So it'd be this one. Okay, and then are these two congruent? Nah, this is angle, angle, side, and this is angle, side, angle, so no way. Okay, we're almost there. Okay, uh, looks like the same problem. Okay, let's go to the next one. Okay, so one last thing to proof, okay? So we marked the EF and HF, right? Okay, so we marked that. Then because of the midpoint, G, then these two segments are congruent, right? And then whoosh, we've got the reflexive. Okay, this is given. Okay, by midpoint, okay, if G is a midpoint, then we can say that EA or EG is congruent to HG, right? So that's there. And then reflexive is the one that's shared, right? FG is congruent to FG, so we put that there. And then what reason are the two triangles congruent? Yeah, yeah, side, 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 right? Okay, we're done. All right, let me get out of here. Y'all have a great test. Let me see, let me turn it off, turn it off.